Okay, so for this test, go ahead and write down everything I write down. For ones that you missed. Okay, so let's take a look at the first one. For A, we're comparing two sides of the inequality there. There's the left side and there's the right side. Okay, all right, so the square root of 25, well, we know that's 5, so 5 plus 2. 5 plus 2 is 7, and then we have this inequality. And then the square root of 9 is 3. So we have 3 plus 4, 3 plus 4 is 7. 7 is less than 7. Okay, so that's not true. So we've stumbled upon the right answer. Okay, so let's go ahead and circle it. But if you missed this one, let's go ahead and look at the other ones also. Okay, because you chose one of the other ones, we'll see why you shouldn't have chosen it. So for B, this is 3 times 3.14. Okay, and then it says that's greater than 9. Well, 9 is 3 times 3. Okay, so 3.14 is going to be bigger than 3. Right? 3 times 3.14 should be bigger than 3. This is a correct statement. Okay. For letter C, the square root of 7 squared. Well, the square root of 7 squared, we see the square root and the square. This is 7. And then the square root of 9 is 3. So this says 7 is greater than 3. That's true. We want one that's not true. And then for D, you have 8 minus square root of 36 is 6. This side is 2. And then over here, we got the square root of 9 is 3. The square root of 4 is 2. So we got 3 plus 2 is 5. So this says 2 is less than 5. Well, that's true also. The only one that wasn't true was A. Okay, so if you missed number 1, write all of that down. Okay. All right, for number 2, which number is plotted on the number line below? This says 5.4 something. Okay, so this says 5.4 something. Okay, so we have this right here is 5.1. I'll write it up here. This is 5.1. There's 5.2. This is 5.3. It's 5.4. 5.5, 5.6, 5.7, 5.8, 5.9. So you know it's between 5.4 and 5.5. So it's 5.4 something. Okay, so we know it's not C. C is 5.1. Okay. Let's go ahead and check B. Okay, so I'm going to add 3.14 plus the 1.6, put a 0 underneath, and let's add here. Okay, so when I add now, I'm going to go ahead and I lined up the decimals, and let's add these numbers. 4 plus 0 is 4, 1 plus 6 is 7, and then 3 plus 1 is 4. This, I don't even get a number in the 5s. I know it's not B. Okay. Let's go ahead and look at this one. Let's divide both by 10. Okay, because they both end in 0, so let's make it an easier number. If I divide 170 divided by 10, I get 17. If I get 30 by 10, I get 3. Okay, so let's go ahead and divide 3 into 17.0, and let's bring up that decimal point. Okay, 3 goes into 17 5 times. 5 times 3 is 15, and when I subtract, I get 2. 3 goes into 20. Well, 3 goes into 20 6 times. 6 times 3 gives me the 18, right? This is 5.6, right? I'm looking for a 5.4 number. Okay, so let's take a look at the square root of 20 plus 1. Well, the square root of 20, the next lowest perfect square is square root of 16. The next highest is square root of 25. Okay, so that's between 4 and 5. That's 4 point something. It's closer to the smaller number, right? It's closer to the smaller 16 than it is the bigger 25. So my options are 0.1, 0.2, 0.3, or 0.4, and it's kind of in the middle. So it's 4.4. Then I have 4.4 plus 1, and that's where I get the 5.4. Okay, so this is the one that I want. Okay. All right, so for this one, for number 3, which fraction equals a repeating decimal? Well, this is 0.3. A is 0.3. C is 6 over 12, right? C is 1/2. I can divide both by 6 and get 1/2. 3/4, that's 3/4, that's 0.75. Oh, the 1/2 is 0.5. None of those are repeating. The one I wanted you to know was repeating was the 1/3. That's the 0.3, but not just 0.3, it's 0.3333, right? Remember, 1/3 is 0.3 repeating, 2/3 is 0.6 repeating. Okay. All right. So this is B is the one we want for that one. All right. So for number 4, a small square garden has an area of 25 yards, so it's a square garden. So let's draw a square. You know, all the sides are going to be the same. How long is each side of the garden? Well, for area, it's length times width. Okay. So the area should equal to 25, right? Area is 25. Instead of length times width, right, for a square, we have a side times the side, right? Because the length and the width are exactly the same. So side times side equals 25. So what does that one side have to be, right? So 5 times 5 equals 25. So that side has to be 5 yards if the area is 25. Okay, and then for number 5, which is an estimate of the square root of 15. Well, the next lowest perfect square is the square root of 9. The next highest is the square root of 16, right? That's 3 and 4. It's 3 point something, right? It's between 3 and 4. You know it's not A. You know it's not D. It's between 3 and 4. It's 3 point something. It's closer to the bigger 4. So what are your options for decimals? 0.6, 0.7, 0.8, and 0.9. Okay. For number 6, which statement is false? Okay, so for which statement is false, the one here that you want to choose is that some integers are irrational. Okay, integers are all rational numbers. Okay, so rational and irrational numbers, they can't share, they can't overlap. Okay, so this would be the false one. Some integers are irrational. Integers can never be irrational. Integers are rational. All right, number 7. Which number falls between 5 and 3/4 and the square root of 6? Key word here, square root of 36. Key word here is between. Okay, so 5 and 3/4, that's 5.75. The square root of 36 is 6. Okay, so you need a number bigger than 5.75 and smaller than 6. Well, A is 5 point, what's 1/2 as a decimal? That's 5.5. Well, 5.5 is smaller than 5.75, so it's not A. This is square root of 25, which is 5. That's smaller than 5.75, so it's not B. The reason it's not D is because it wants between. It has to be bigger than 5.75, so that's why it's not D. The only one that is bigger than 5.75 and smaller than 6 is your option C. Alright, number 8, how would you classify the square root of 24? Well, the square root of 24 is an imperfect square. It's going to turn out to be a non-terminating, non-repeating decimal. Okay, so that's one of our visual indicators of irrational numbers. Okay, so the square root of 4 is an irrational number. Number 9, between which two whole numbers, okay, is the square root of 50? Well, the next lowest perfect square is this is square root of 49. We got the square root of 50 right here, and then the next highest perfect square is square root of 64. Okay, so between which whole numbers is that? That's between 7 and 8. Okay, so 7 and 8 is what you want. Okay. Number 10, a student divided a 5-foot ribbon into 3 equal parts, 5 over 3. What type of number describes the length of each part? Well, it's not an irrational number. It's not going to be C. Doesn't have one of our 3 indicators, the 3 dots, pi, or square root of an imperfect square. So we know it's not going to be that. So since it's not irrational, it has to be rational, right? And then if we go further, whole numbers and integers, when they're simplified, you won't see a fraction, a decimal, or a square root. Okay, so we see a fraction here. So it's just a rational number. All right, number 11. Which is the decimal equivalent of 16 over 5? Let's set up our division. 5 into 16. Let's put a point 0, second 0 there just in case we need it. Let's bring up our decimal point. 5 goes into 16 3 times. So I know it's not going to be A. I know it's not going to be B. 3 times 5 is 15. Let's go ahead and subtract here. 16 minus 15 is 1 and bring down the 0. Okay. 5 goes into 10 2 times. 2 times 5 is 10. I get my remainder of 0 there. So it's 3.2. For number 12, a number line shows the whole numbers for 0 to 10, which is the most accurate description of where you would plot the square root of 30. So let's go ahead and write over here on the side the square root of 30. The next lowest perfect square is square root of 25. The next highest is square root of 36. That's between 5 and 6. So let's cross out anything that says otherwise here. C, it says between 6 and 7. D says between 7 and 8. So it's between 5 and 6. And they're both, it's kind of halfway, so it's kind of in the middle. It's close to 5.5, okay? But it should be a little bit closer to the smaller number. It should be closer to the 5. Okay, so we're going to choose A. A little bit closer to the 5. Right? 30 is 5 away from 25. It's 6 away from 36. Number 13. So whole number was written for you here because you got some, or underlined for you because you got some options that are in decimal. So you want it closer to the nearest whole number. The square root of 60. Well, the next lowest perfect square is the square root of 49. The next highest perfect square is the square root of 64. That's between 7 and 8. And you want it nearest to the, choose the nearest whole number. The nearest whole number is the 8. Okay, it would be 7 point something. Okay, but it's closer to the 8. Alright, solve this equation for x. So you have x squared equals 81. And you can do 9 times 9 equals 81. Okay? But also, negative 9 times negative 9 gives you the 81. Okay? So you have to account for the positive and the negative. That's option B. Number 15, what is the best explanation as to why an integer cannot also be an irrational number? Well, an integer is a rational number. Okay? So if you look at option B, integers are rational, and rational numbers can never be irrational. Okay, so for this one, an integer is a rational number. Okay, all right, let's go to the last page. All right, so why are square root of 2 and this non-terminating decimal number that doesn't repeat, why are they irrational numbers? Choose the best explanation. So let's break each down. The square root of 2 is an irrational. It is not an irrational number. That's not true. The square root of 2 is an irrational number. They are both the same number. Actually, they turn out to they are not the same number. And you'd have to be able to prove that. The square root of 2 is not the same as 1.58113887. They both have decimal expansions that repeat. They don't. This one does not repeat. Okay, the ... means non-terminating, non-repeating. But the one you want to choose is D. They both have non-terminating, non-repeating decimal expansions. Okay, square root of 2 is non-terminating, non-repeating, and this one's dot dot dot. Right? Square root of 2 is because it's an imperfect square. Number 17. So the square root of 2. So let's take a look at the square root of 2 here. The next lowest perfect square is the square root of 1. The next highest is the square root of 4. So that's between 1 and 2. Okay, so it's 1 point something. So you know it's not going to be B, you know it's not going to be D. It is closer to the smaller one. Okay, so what are your options for decimals? 0.1, 0.2, 0.3, or 0.4. Right, so it's between 1 and 2. 1 point and 1.4. Okay, and then number 18. So I have here for 18, we just estimated this to 1.4. Okay, so 1.4, right, is going to be less than 1.5. Right, we estimated the square root of 2, so this one, the options.